Good evening. Welcome to the QCIS channel. On this channel, get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and what I'm going to do this evening is present another project for you. And it's very important that you listen to this video because if you are an engineering major, you want to get into industrial engineering or manufacturing engineering or mechatronics, mechanical engineering, this video is for you. Why? Because I'm going to talk about creating a new product. Now, this is a video from my course, TLI 315, New Product Development. Dr. Stacy Little is the instructor, and this is a Purdue University course. Now, what I'm going to present to you is PowerPoint. Let me share my screen. Now, since I work in construction, what I like to do is do products that are in construction. Construction is a industry that builds infrastructure. So, regardless of what industry you're in, there's always room to develop and improve new products. So, to outline everything for you, I'm going to talk about high value concrete. Again, my name is Leon Jones. This is Project 4. It's due April 30th, 2023 from Purdue University, TLI 315, New Product Development. And Dr. Stacy Little is the instructor for this course. Now, to outline everything, there's a lot of slides in this presentation. So the first 29 slides, I'm going to give you charts and I'm going to give you what's inside. It's called high value concrete. Now, there are a lot of divisions of high value concrete. And basically, when we deal with high value concrete, it's high performance concrete. And that's due to the materials. That's also due to how it sets and how this concrete passes all the compression tests. Now, as I move into the next slide, we also call it specialty concrete, high-end value materials. Okay, what is high-value concrete? Basically, all today's concrete is high value. The cost of material is small, the cost of placement is significant, cost of replacement is high. That's for any project. So I wanted to develop a product that is cost effective but strong. Now, high value concrete is generally associated with high performance. Now, what is high performance? Well, you have high early strength concrete, high strength concrete, high durability concrete, self-consolidating concrete, reactive powder concrete. It's all brand new forms of high value concrete. Now, the characteristics of high performance concrete. Again, we're looking for the high early strength, the high strength, the high modulus of elasticity, high abrasion resistance, the high durability and long life in severe environments. As you know, concrete makes a good base. It can last a good 50 years. Now, we're also looking for low permeability and diffusion, and of course, resistance to chemical attack. Also, we're looking for high resistance to frost and dicer scaling damage, toughness and impact resistance, volume stability. Of course, you want the ease of placement, the compaction without segregation. When something segregates, you mix it up. You don't want segregation. And also the inhibition of bacteria and mold growth. Now we're going to get into a little chart right here. Talk about the materials used in high performance concrete. First of all, the material, Portland cement. We have blended cement, fly ash. We have calcined clay and metakaolin. We also have calcinized shale, superplasticizers, high range water reducers, hydration control admixture. And for our primary contribution and desired property, we're going to use the cementing material for durability, high strength. What we're going to do, we're going to have some flowability. It means how it comes off the chute. And now all this is going to be tested in the lab. So we will get the testing results to see if we have to go back and make any changes in the design. We're going to reduce water cement ratio, and we're going to have a control setting. Again, the materials used in high value concrete are accelerators, and you need accelerator in a wintertime, especially when you're pouring concrete, because you want to set it quickly. And remember something too, concrete, it cracks in the wintertime, it expands in the summertime. So you want to have control joints in your concrete. You have your retarders, your corrosion inhibitors, water reducers, shrinkage reducers, ASR inhibitors. You also have optimally graded aggregate. Aggregate is stone. That's what the AGGR period is. It's aggregate. Polymer, they put on bridges. And then what are we looking for? Control setting. We want to also accelerate setting. That's what accelerators are. When we deal with corrosion inhibitors, we want to control steel erosion, because when you place concrete, you have what we call reinforcement bars, known as rebar, that adds little tension and strength to the concrete. And you want to reduce cement and water content and shrinkage, and you want to control the alkali silica activity. Always want to improve workability and, of course, durability. Now, some facts that you have to understand. And when I deal with any type of product, what kind of numbers do we need? Well, for high strength, we have what we call ASTM. That's the test method. ASTM stands for American Society of Testing of Materials. Now, here's the criteria: 70 to 140 megapascals. Now, when we deal with pascals, we're dealing with pressure, 28 to 91 days. That's for high strength. Now, high early strength, this is our spec right here. The ASTM C39, 20 to 30 pascals, 3 to 12 hours or 1 to 3 days. That's the criteria. Then we deal with high early flex strength under a different specification, ASTM C78, 2 to 4 megapascals, 3 hours or 1 to 3 days. Abrasion resistance, another specification, 0 to 1 millimeters depth of water. And this is what you use to test all of your specimens. You can't do anything without a spec. Chloride penetration, that's AASHTO. AASHTO is the American Association for State Highway Transportation Officials. They deal with your state roads. That's a spec. less than 0.07%, CI at 6 months, low absorption from your spec ASTM C642, 2% to 5%, and your high modulus of elasticity, ASTM C469, more than 40 gigapascals. Okay, again, when we deal with high early strength concrete, and this is all under high value concrete, we also have, again, ASTM C39, ASHTO T22, 20 to 28 megapascals, which is when we convert it over, because when we deal with pascals, that's metric. What we're dealing with is pounds per square inches here in America. And basically, when we lay concrete down for any type of infrastructure, we want 3,000 to 4,000 PSI, 12 to 3 hours or 1 to 3 days. And again, for your high early flexural strength, when you have specifications as well, you're going to have two. You're going to have ASTM and you're going to have ASHTO. We're looking at 300 to 600 PSI at 3 to 12 hours or 1 to 3 days. Also, more data for you. High early strength concrete may be achieved by type 3 or high early strength cement. When we deal with the content, we're dealing with, if you're in metric, 400 to 600 kilograms per cubic meters. When you're dealing with English like we utilize here in the United States, 675 to 1,000 pounds per cubic yard. Low water resistance, and that's our materials ratio by mass, 0.20 to 0.45 mass, and a higher freshly mixed concrete temperature and a higher curing temperature. This is what you want to do to achieve the workability of your concrete. And again, this is basically a brand new product. So there are a lot of risk you take, but if you get it right, sell this product, it can give your company a good reputation, and companies can generally make good profit and gain customers. And in the second half of this video, I want to give you the business aspects of this product, how we can sell it. All right, high early strength concrete can be achieved by chemical admixtures, silica fumes, steam, or autoclave curing, insulation to retain heat of hydration, special rapid hardening cements. Now, what I'm giving you right now is, just think of it as we're in a lab and we're developing this product, and we're running different tests on this product just to see what our data is going to come to be. And more data for you. We're in our high strength, and most of us, when we get to the comparison, most of structures use ready mixed concrete. And generally on that kind of concrete, you're going to go from 300 to 600 PSI. And when we deal with high strength concrete, by definition, that's 10,000 PSI. That is really high. That's 3 times higher than the 3,000 and 4,000 PSI that we want. We're going to get into the aggregates. This is what is put inside your concrete. Data. We want 3/8 to 1/2 inch nominal maximum size. Why? Because that will give you that maximum or optimum strength. And what we want to do is we want to combine single sizes for required grading, and that allows for closer control and reduced variability in concrete. And anything for 70 megapascals and greater, the sand should be right around 2.8 to 3.2. Now, If it's any lower than that, your mix is going to be sticky. And it's going to be a bad mix. And we'll have to go right back to the drawing board, find out where we had the issues, and start all over again. We also have supplement 3 cementing materials: fly ash, silica fume, slag. Dosage rate is basically 5% to 20% or higher by mass of cementing material. Admixtures. Your admixtures, your retarders, your plasticizers, your water reducers are mandatory in high strength or high value concrete. Now, when you're dealing with air and training, admixtures are not necessary or desirable in protecting high strength concrete. Now, however, when we run the test, air is mandatory where durability in a freestall environment is required. And that's basically used in structures. In recent studies, we have the air required, the water cement ratio, 0.30, air required, and under 0.25, no air required. That's the data. Okay. We also worry about placing, consolidation, and curing. Why? Because delays in delivery and placing must be eliminated. Consolidation is very important to achieve strength. Now, when we slump it, we basically have a slump cone. And what we do, we put concrete in that slump cone. We ride it 25 times, 3 layers apiece. And then what we do, we lift the cone about 45 seconds from the concrete. And you'll see that the concrete, if it is in the shape of the cone, that concrete is very stiff. If it's watery, the concrete is liquidy. Now you want 7 to 9 inches, which means the concrete is going to be on a liquid side. And also you want little, if any, bleeding, fog, or evaporation retarders have to be applied immediately after strike off. Again, when you are testing, before you lift the cone off the concrete, you got to strike it off, utilizing what we call the steel rod. And for the most part, when we're testing concrete or we're making specimens, we need at least 7 days for it to cure. Curing means it's getting hard. We want to see what our test results are going to be after 7 days. And generally, if it's around 60% cured, that's pretty good. High durability concrete. Well, we focused on that in the 70s and 80s. Today, we're generally dealing with high durability. Now, when we deal with high performance concrete or high value concrete, now from my research, these are the issues that I normally would come up with: blast resistance, permeability, freeze thaw, alkali silica reactivity, corrosion rates of rebar. That means your rebar, your reinforcement bars are corroded. Then abrasion resistance. All right, high durability concrete. Now this is actually a product, the Confederation Bridge in Northumberland Strait, which is in Prince Edward Island, New Brunswick. And here's the data. In that mix, the cement, 671 pounds per cubic yard, fly ash, 76 pounds per cubic yard, silica fume, 72 pounds per cubic yard, have a water cement ratio of 0.30. Then you also have what we call water reduction, 47 ounces per cubic yard. And you also have a HRWR, which is 83 ounces per cubic yard. And your air, 5 to 8%. And generally your strength, 8,700 PSI, which is really strong. And under high value concrete, self-consolidating concrete, or we call it self-compacting concrete. Why? Because it basically consolidates on its own. And this was concrete developed in the 1980s in Japan. And this type of concrete, it increased the amount of fine material like fly ash or limestone. And it had plasticizers in it as well. Now, basically, this type of concrete is got the same durability. And when I mean durability, it doesn't take a lot of load. Like if you're on a road, trucks have a heavy load. Buildings have loads, live loads, strength, same as conventional. Conventional concrete is ready-mix concrete. Self-consolidating concrete, and here's the graph. And this is what we also use in soil mechanics as well. Well, this is 10% cement, 18% water. Then you have your air, 2% to 8%, 2%. Then you have your fine aggregate. When something is very fine, like soil, it's like powder. And when you compact it, there's no air. And something is coarse, which this is what regular mixes have. Coarse, you have voids. Stone is very coarse. Number 8 stone, number 53 stone, very coarse. But these are the aggregates plus sand. Sand is a fine. This is what makes up the mix. And from my graph, this is the percentage of material that goes into making this regular mix. This is the regular mix at the top, and at the bottom, this is your self-consolidation or self-consolidating concrete. Now, if you look at this graph, for the regular mix and the self-consolidating concrete, you see both of them require 10%. 10% cement. Both of them also require 18% water. Now, when you get to the air, things are a little different. Well, you need 2% air for regular mix, but it's a little more flexible on air when we deal with self-consolidating concrete, 2% to 8%. And when we deal with the fines, you have more fines. Actually, let me correct you. You have 8% fines. 8%, this is where everything starts to turn different with self-consolidating concrete because you have more fines. So let me go back and give you the correct information about the air. The air for regular mixes and high value or self-consolidating concrete, it's 2%. You see the graph when we get to the fines. You don't need fines unless it's fine aggregate. Fine aggregate is the stone that goes into this concrete. That's at 25%. But when we deal with fines, sand is a fine. Now you need 8% fines for your self-consolidating concrete. Now your aggregate, when it comes to the regular mix and your SCC, self-consolidating concrete, you have 25% fine aggregate, 26% fine aggregate. What's also different with the regular mix and the self-consolidating concrete is I have compared the two. You have 45% coarse aggregate, so that's more stone you have to put in the regular mix. And for your coarse aggregate, it's less stone, it's 36%. So on this graph, I'm presenting to you the regular ready mix and the self-consolidating concrete via comparison from this data. All right, self-consolidating concrete for a power plant in Pennsylvania, mixed proportions. This is good data right here. And if you're going to design concrete in the lab, in order to sell it, you need to come up with some good numbers. Well, for Portland cement, type 1, 500 pounds per cubic yard. For slag, 215 pounds per cubic yard. Here's your coarse aggregate, right around 1,140 pounds per cubic yard, and right around 1,730 pounds per cubic yard. That's your fine aggregate. And then you have your water. Let's put water in all concrete, 286 pounds per cubic yard. And you have your plasticizer. Now, again, plasticizer type F is based off of this specification, ASTM C494. And for your polycarboxylate base, it's 35 ounces per cubic yard. So your AE mixture as needed is 6% plus or minus 1.5% air content. And what do I mean by that? I'll tell you right now. So if I'm running an air content test, if I have 6%, I'm allowed to go 1.5% lower, which would be 4.5. And of course, 1.5% above 6 at 7.45, at 7.5. So my specification would actually call for a variance or range between 4.5% and 7.5% for air content. Properties, RPC, high strength, 200 MPa, can produce to 800 MPa, very low porosity. Now, properties achieved by this type of concrete, you have a maximum particle size of basically under 300 micrometers. Optimized particle packing, low water content, steel fibers, heat treatment. This is what it looks like. Getting some more content. This is data. These are all the properties that are associated with RPC. Again, RPC is reactive powder concrete, compressive strength, that's a big one. We have flexural strength, tensile strength, modulus of elasticity, fracture toughness, freeze thaw, carbonation, and of course, abrasion. And this is all the data that I have actually researched, so I can put it in the PowerPoint to show you how everything comes together. And this is what I would be doing if I was producing a new product. There's a concrete bridge. It's what one looks like after they use this reactive powder concrete. It's all high value concrete, high performance concrete. All right. This is what goes in a lot of your concrete. You have your raw material components. And this is the process, how it works. You have cement, sand, silica quartz, silica fume. You have microfibers, could be metallic or polyvinyl acetate. Then you have your nanofibers, which we call them mineral filters, superplasticizer, and water. In order to understand concrete, I can put numbers down, I can put charts down, but I have to have the right material in order to produce the concrete. And it has to go through a process. And then once it goes through a process, the prototype would be to test it, to see if it would be available for use by contractors, the public. All right, again, what's in a typical ductile mix? This is your chart, breaks it down. Your cement, your silica fume, your crushed quartz, your sand, your fibers, your plasticizer, and your total water. Now, again, this is all metric. And this is all your water cement ratio, 0.20. This is your graph of what percent is in this ductile mix. Cement, silica form, silica fume, crushed quartz, sand, fibers, plasticizer, and total water. Now, first slides that I did, I gave you some information about the product, gave you data about the product, how it's produced, how I tested it. So in your head, think about it now. Got a prototype. Now we got to launch the product plan. And basically, what are we thinking? We're thinking about the durability, the resistance to extreme weather, how this concrete is going to hold up to heavy loads. What makes it work on just about any construction product? Again, when it comes to selling concrete, got to narrow your market down to those who are likely to buy your products. Otherwise, mass marketing efforts meant to persuade builders to buy your concrete products could be proven to be ineffective, and also you're risking your company's money. All right. Product concept, high value concrete. Well, and we're going to be comparing because we have high value concrete and we have ready mix concrete. Well, for high value concrete, it may be defined as concrete with strength and durability significantly beyond those obtained by normal means. And what is that? The required properties for concrete to be classified as high performance, therefore depend on the properties of normal concrete achievable at a particular time and location. Now, ready mix. This is the concept statement for ready mix. Now, before you had your product statement for my product, high value concrete. Getting now into the concept statement for ready mix concrete. And basically, ready mix concrete is it's preferred concrete that is, a lot of builders use it now because you can mix it on site. The mixture has a higher precision, and having concrete ready to pour reduces confusion on the work site. So when we deal with ready mix concrete, it can be used for buildings, roadways, walls, and more. Okay, question there about high value concrete. If I was going to ask potential customers, here's what I'm going to ask. What is the curing time for high value concrete? How much weight can high value concrete support? Does high value concrete need any type of reinforcement? Can stains be removed from high value concrete? Can decorative finishes be applied to high value concrete? And also, since a lot of contractors use ready mix concrete, well, what's the difference between high value concrete and ready mix concrete? How can you ensure high value concrete is of high quality? And dealing with green construction, is high value concrete a sustainable material? And what factors had an impact on high value concrete? Sales forecast. For purchasing high value concrete, using the ATAR ATAR model. ATAR stands for awareness, trial, availability, repeat, and buy. So from my construction industry, I knew generally the market because it's made up of a lot of contractors and some individuals who are in the private sector. They buy concrete. That's my target market, 10.5 million customers. So to break everything down, I took my awareness, my 10.5 million, and said awareness was right around 0.60, and I came up with 6.3 million. And for my trial, 6.3 million times 0.20. You'll see how these numbers are going to work out in a minute. So when I got my 6.3, I multiplied it by 0.20 and got 1.26 million. Again, for my trial, 6.3 million times 0.20, and I got 1.26 million. Availability, take 1.26 million, multiply it by 0.75, 9.45 thousand. I repeat by 9.45 thousand times 0.50 equals 475, almost 473,000. Say 472,500. Now, target market. What I did, I took all the percentages and multiplied them together and got 4.5%. Now, because I've been in the construction industry for a long time and I used to do estimates on concrete, I chose the nation's average number. What is the cost? What would my cost be? What would I be selling it for? And 4.5% out of the 10.5 million customers, my sales forecast would have me coming out with roughly 472,500. That would be my sales. Now, how much would I make off of 472,000? Well, here's what my sales forecast would be. If everything comes out right, because generally cost of concrete is $125 per cubic yard. Well, I'm going to take by 4.5%, and this is where this number comes from, because essentially I would take 10.5 and multiply it by 4.5% to come up with 472,500. Well, to get my sales forecast, take 472,500 and multiply it by $125 per cubic yard, and I would come out with 59 million. That's if everything worked out correctly. As I move on, what about the product and technology description? Well, high value concrete, basically in its simplest form, is a mixture of paste and aggregates. Aggregates we can call stone. Now, the paste is basically composed or compiled, but I'm going to use composed of essentially Portland cement, water, and what it does, it coats the surface of the fine, which are small, and coarse, larger aggregates. When I mention aggregates, I'm talking about stone, through a series of chemical reactions called hydration. Now, this is actually the technology and the process that I'd be using to create this product. And what happens after that? The paste hardens and it gains strength to form the rock-like mass known as concrete. Within the process lies the key to a remarkable trait of concrete, because it's plastic and malleable when newly mixed and strong and durable when hardened. And when we take all of the materials and put them together through a process, we develop high value concrete. Now, the way I did it is I utilized basically the ready mixed concrete. Took some of the ingredients to see if I can make a stronger concrete that's going to be cost effective. Target market. Well, I have a target market. I look at my capabilities and determine whether you have the manpower and resources to go after large concrete jobs. Now, I'm utilizing this concept from a smaller market. And I say that because the equipment you own plays a role in the market you choose. Now, large equipment is less likely to fit into homes, but smaller equipment doesn't work fast enough to get large construction projects or commercial projects done on time. So I'm starting out with a product, creating concrete, and I like big equipment. Start looking small. Look at the homeowners. Use them as a target market. Build a repertoire. Not only do you look at homeowners, look at interior designers and remodelers as your target market. Too often, companies want to go after the big jobs, and it's a risk when you're putting a brand new a product out on a big job. What if it fails? And before you release any product, utilize a prototype, test it. Because basically, outside of homeowners, interior designers, and remodelers, target market is going to basically consist of contractors that work on large public or private construction projects. Now, to initiate an effective marketing plan, you're going to need to narrow down the market by the type of concrete you sell, such as pavement, piping, masonry, or decorative products. Position or product positioning. Say product positioning. Well, what am I going to do? Approach contractors, remodelers, and interior designers starting off small. It's going to require networking through local builder associations, referrals, setting up appointments to meet with them to discuss their project needs. So you have to do a little good old-fashioned marketing. You can also use social media as well. Social media is a good tool, but if you're just starting out or you're developing a new product and you are a medium-sized or even a larger company, well, get some of these individuals into your target market because they can become your customers. See, again, in the industry, some of your larger companies develop new products. You want to keep your customers, but you want to bring in a new pipeline to your market so you can make greater profit for your company, because construction is very competitive, particularly here in Indiana. Have a number of contractors bidding on a lot of these same jobs. Unique value for target market. Again, if you lack big equipment, start looking at homeowners, interior designers, and remodelers as your target market. Build up a clientele. Get some jobs completed with this product. And then once you get a little word of mouth around, you can also put this product out on social media. Then you can get into the bigger projects with your new product. Now, if you are a company that is looking at high-value concrete as one of your materials you want to use, well, I would even go after some smaller projects as well. Remember something, concrete costs $125 a cubic yard. You don't want to waste your money, send your concrete out to your clients and it fails. Make sure it's properly tested and you follow the specifications as well. Trademark issues. Basically, I don't see any issues with trademarks or patent issues because my product name is named HighValue Concrete. Okay. I was starting everything off. I'll go into smaller clientele. individuals who specialize in restaurants or residents and convenience stores. And of course, strip malls. Brand equity. Have an emotional bond with customers, quality of customer strategy, branding strategy, product innovation, and social media reputation. That means make sure that your social media page and even your website are up to date. Concrete packaging. Okay, this one. Most of your concrete should be waterproof, as absorption of carbon dioxide and moisture from the air can largely affect the quality of the product with time. Now, when it comes to basically shipping concrete, yes, there's concrete that comes in bags. It's powder. It's basically 3-to-1. And 3-to-1 is the water cement ratio. But most of your concrete, when it goes to job sites, and high value concrete will be no different. It's going to be shipped by truck. Market testing. What I would do, I'm going to test the market. I'd run a SWOT analysis: strengths, weaknesses, opportunities, and threats. And generally, market opportunities are always expected to open up a growth window for new entrants in the market. So what it does, it helps to understand unmet needs or an untapped potential in the market. So offering a small sample is the best way to test a new market. And basically, when it comes to a timeline for launching new construction materials, but particularly a concrete material, generally would take 1 to 2 years. And that's because of the design and testing process and the availability of materials. And that concludes this presentation. Well, before I conclude it, I have what I call my high value protocol. Basically, I select the appropriate slump value, provide the mass, aggregate size and shape, select the cement type, because high value concrete has different types of concrete mixes involved with it. Once I select the concrete type, then I'm going to do some experimental testing of the aggregates and cement to get a specific gravity and fine aggregate zone. I'm gonna get a concrete target strength. I'm gonna determine water cement ratio, the calculation of water cement for the concrete mix, calculation of the concrete or cement content for the concrete mix. I have also estimation of coarse aggregate for the concrete mix. And then I'm gonna calculate the fine aggregate quantity using the fresh cement estimated weight, already derived quantities of coarse aggregates, water, and cement. And I'm gonna make an adjustment of moisture content for the fine and coarse aggregates. Then run a trial mixture overall from the overall material that's been estimated. Then I'm going to have a derivation of the effective mix ratio of ingredients. That is my high value concrete protocol. And now that concludes this topic on high value concrete. And if you like what I just presented, please comment, share, and subscribe. And I'm going to post this information up on my LinkedIn page. Also going to post it on my YouTube page. And if you want some social and political content as well, you can check out my other channel, the 411 Talk Zone Radio Show on YouTube as well. Now, if you cannot find this channel, which is the QCIS channel, and the 411 Talk Zone Radio Show channel on YouTube, check both of those channels out on Twitter as well. Now, for this channel, the QCIS channel, since it is an education channel, I will also post this information again on my LinkedIn page. And once again, thank you for viewing this content, brand new product of high value concrete here on the QCIS channel. And on this channel, I give you a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. You all have a wonderful and gracious evening.